A chatbot can answer in seconds, explain code, write poems, and sound confident while doing it. But behind the screen, there is no tiny person thinking. There is a system turning your words into numbers, predicting what should come next, and checking the result against instructions. The first idea to understand is simple. A chatbot does not understand language the way a human does. It does not hear your voice, imagine your childhood, or feel curiosity. It processes patterns in text. That can still be powerful, because human language is packed with patterns about the world. Everything begins with the prompt. Your prompt is the text you send to the chatbot. It might be a question, a command, a paragraph, or a whole document. The chatbot treats that input as the beginning of a sequence, then tries to continue that sequence in a useful way. Before the model can work with your prompt, it breaks the text into smaller pieces, called tokens. A token can be a whole word, part of a word, a number, or punctuation. The model does not directly see sentences. It sees a chain of token IDs. Those token IDs are then turned into mathematical representations. You can picture each token getting a location in a huge space of meaning. Tokens used in similar contexts tend to have related representations. This is why a model can connect words like doctor, hospital, and patient without using a dictionary in the human sense. The model is the core engine. In modern chatbots, it is usually a large neural network based on a transformer design. That means it has many layers of math that adjust the token representations again and again, using patterns learned during training. A key part of the transformer is attention. Attention lets the model compare tokens with other tokens in the same context. In the sentence, the trophy would not fit in the suitcase because it was too big. Attention helps connect the word it to trophy, not suitcase. This comparison is why wording matters so much. If you ask, explain batteries to a child, the model sees a different context than if you ask, explain battery chemistry for an engineering exam. The topic may be similar, but the surrounding tokens guide the style, depth, and likely answer. At the heart of the process is next token prediction. The model looks at the current sequence and estimates which token is likely to come next. Then it adds one token, looks again, predicts another, and repeats. A long answer is built one small step at a time. If the prompt says peanut butter and, many continuations are possible. The model might give jelly, bread, bananas, or a recipe. It is not searching a single stored sentence. It is weighing possibilities based on patterns it has learned from many examples of language. Training is how the model learns those patterns. During training, the system sees huge amounts of text and repeatedly tries to predict missing or next tokens. When it guesses poorly, its internal settings are adjusted. Over time, it becomes better at modeling language patterns. If this kind of clear technology breakdown is useful to you, consider subscribing. We are building a simple map of how modern AI works, without hype and without mystery. Now let us go one level deeper into why chatbots can sound helpful instead of just completing random text. A raw language model is mostly trained to continue text. A chatbot needs to follow instructions. So after basic training, many systems are tuned with examples of helpful answers, safer refusals, better formats, and conversations. This tuning shapes the model into something that behaves more like an assistant. Some chatbots also use human feedback. People compare different answers and mark which ones are more helpful, honest, or safe. The system can then learn preferences about tone and behavior. This does not make the model conscious. It gives the model stronger patterns for what good responses look like. When you chat, your message is not always the only instruction. There may be system instructions that define the assistant's role, safety rules, formatting rules, or tool rules. Your prompt sits inside a larger context that the model uses when deciding what to say. The model can only consider text inside its context window. Think of it like the visible papers on a desk. If an earlier detail is inside the window, the model can use it. If it is outside the window, the model may not have direct access to it unless another system brings it back. This leads to a common misunderstanding. People say the chatbot remembers everything. Usually, the model is reacting to the current conversation and any memory features the app provides. The underlying model does not magically know every past chat unless that information is included or retrieved. After the model estimates possible next tokens, another step decides which token to actually output. This is called decoding. If the system always picked the most likely token, answers could become repetitive or dull. If it allowed too much randomness, answers could become strange or unreliable. One setting, often called temperature, affects how adventurous the selection is. Lower temperature usually makes the model choose safer, more predictable tokens. Higher temperature can make responses more varied and creative. It is like changing a storyteller from careful textbook mode to playful brainstorming mode. Another decoding idea is limiting the pool of possible tokens. Instead of considering every possible next token, the system can choose from a smaller group of likely options. These settings help balance variety with coherence, but they do not guarantee truth. They only affect how text is selected. Chatbots sound smart because language contains traces of reasoning. Explanations, arguments, examples, and code all have structure. When a model learns those structures at a large scale, it can produce answers that look like reasoning. In many cases, that output is genuinely useful. The same mechanism can also fail. A sentence can sound polished and still be false. The model may produce a response that fits the style of an answer without having reliable evidence. Fluency is not the same as accuracy, and confidence in wording is not the same as certainty. When a chatbot gives a plausible but wrong answer, people often call it a hallucination. It might invent a book title, confuse two people, create a fake citation, or give an outdated fact. The model is still doing next token prediction. It is just predicting a believable continuation that is not true. Confident wrong answers happen for several reasons. The training data may contain errors. The question may ask about something rare. The model may not have enough context. The system may be rewarded for giving a complete answer rather than admitting uncertainty. All of these can push it toward guessing. A basic language model does not automatically check a live database before every sentence. It generates text from learned patterns and current context. Some chatbot products add tools, search, or retrieval. But without those additions, the model may not know whether a specific claim is current or verified. Retrieval helps with this problem. In Retrieval Augmented Generation, a system searches documents, websites, or a company knowledge base for relevant information. Then it places useful excerpts into the model's context. The model can use that retrieved material when writing the answer. Retrieval can make answers more grounded, especially for company policies, technical manuals, or recent information, but it is not magic. If the search finds the wrong document, misses the right one, or gives confusing snippets, the model can still answer poorly. Better ingredients usually help, but cooking still matters. Some chatbots can use tools. A tool might be a calculator, a search engine, a code runner, a calendar, or a database. The model decides when to call the tool, reads the result, and then writes a response. This is how a chatbot can go beyond text prediction alone. Even with tools, the model remains the coordinator. It interprets your request, chooses a path, formats the tool input, and explains the output. If it misunderstands the goal, calls the wrong tool, or ignores the tool result, the final answer can still be flawed. Good prompts help because they reduce ambiguity. Instead of asking, "Tell me about solar power," you might ask for a beginner explanation, 5 key trade-offs, and 1 everyday example. You are not casting a spell. You are giving the model clearer context for what kind of answer should come next. You can also ask the chatbot to separate facts from assumptions, say when it is unsure, and list what would need verification. This does not make it perfect, but it encourages a safer answer shape. For important topics, you should still check primary sources or trusted experts. One mistake is thinking a chatbot is a database. A database stores records and retrieves exact entries. A language model generates likely text. It may know many facts because those facts appear in patterns, but that is different from looking up a guaranteed record on demand. Another mistake is thinking the model has intentions like a person. If it flatters you, refuses a request, or gives a confident answer, that behavior comes from training, instructions, and probability. It may feel social because conversation is social, but the mechanism is mathematical. Chatbots are especially useful for drafting, summarizing, explaining, brainstorming, translating, and helping people explore ideas. They can be strong when the task has clear context and the answer can be checked. They are weaker when exact, current, rare, or high-stakes information is required without verification. So a chatbot is not magic, and it is not just autocomplete in the old sense. It is a layered system. Text becomes tokens, tokens become numbers. A model predicts continuations. Decoding selects words. Instructions shape behavior. Retrieval and tools can add outside information. The best way to use chatbots is to treat them as powerful language partners, not unquestionable authorities. Give clear context, ask for reasoning, verify important claims, and remember that a smooth answer can still be wrong. Understanding the machine makes the magic more useful. Now I want to hear from you. What part of chatbots still feels confusing? Prompts, training, retrieval, tools, or hallucinations? Leave a question in the comments or suggest the next AI topic you want explained in plain English.